Welcome to the Salmon Runs YouTube. Enjoy the video.
You start by confirming prerequisites and grabbing the first datasets. You need clean, representative examples so the model learns general patterns. Install Python, CUDA, and your chosen ML framework, then verify a GPU runs small test training. Once done, scaffold a project, config files, data loaders, and simple model classes. You should commit a reproducible environment and a tiny end-to-end training script that runs in minutes, so you can iterate quickly and catch data or compute issues early. Now you build the model and the training pipeline. Choose an architecture that matches your data modality and capacity requirements so training converges. Implement efficient data batching, mixed precision, gradient accumulation, and a robust optimizer with a learning rate schedule. Make sure to add validation steps and checkpointing to resume from interruptions. Once training starts, track loss, perplexity, and sample outputs regularly. Adjust batch size, weight decay, and augmentation if you see overfitting or unstable gradients to stabilize progress. Finish by fine-tuning on target data and preparing the model for deployment. You should reduce the learning rate, enable early stopping, and calibrate outputs for safety and bias. Once performance is stable, export to a runtime-friendly format, containerize with GPU drivers, and create an inference API with batching and caching. If things go wrong, first inspect the data pipeline and validation set, then test for exploding gradients or wrong normalization. Fix by clipping gradients, reinitializing norms, or simply.
Thanks for watching. Consider subscribing if we helped you.